Good morning, students. Today's topic is very important in chemistry, that is ions and ionic bonds. So concentrate yourself. We are going to start now. Formation of the ions. Ions are charged particles. Ions are formed when atoms lose or gain electrons. Atoms lose or gain electrons in order to achieve a noble gas configuration. Metal atoms lose their valence electrons to achieve a noble gas configuration. And when metal atoms lose their valence electrons, a positive ion that is called cation is formed. Examples are here. Group 1 metal lose 1 valence electrons to form ions with charge +1. For example, lithium electron configuration is 2,1. Last electron will be lose to get noble gas configuration. So lithium will have +1 charge and the remaining electron configuration will be 2. Sodium electron configuration is 281. So last electron will be loosed to get noble gas configuration. So because of the last electron that is loose, sodium will have a charge +1. The remaining electron configuration will be 28. Potassium electron configuration is 2881. And potassium will lose the last valence electron to get noble gas configuration. So we'll have +1 charge. And this will have electron configuration of 288. Likewise, in the same method, group 2 metal atoms will lose 2 valence electrons to form ions with charge +2. Beryllium electron configuration is 2,2. Will lose last 2 valence electrons to get 2+ charge, and this will have electron configuration of 2. Magnesium electron configuration is 282. Will lose the last 2 valence electrons to get charge of 2+, and this will have electron configuration of 28. Calcium electron configuration is 2882. Will lose the last 2 electrons to get noble gas configuration. Will have 2+ charge, and this will have electron configuration of 288. In the same method, group 3 metals lose 3 valence electrons to form ions with charge +3. For example, aluminium is having electron configuration of 283. Last 3 valence electrons will be loose. To get noble gas configuration, will get charge +3. So this will have electron configuration of 28. In this same way, non-metal atoms gain electrons to achieve a noble gas configuration. And when non-metal atoms gain electrons, will have negative ion, that is anion is formed. For example, group 6 non-metals gain 2 electrons to form ions with charge -2. For example, oxygen is having electron configuration 2,6. Now oxygen will gain 2 electrons to get charge of 2-, and now this will have electron configuration of 2,8. Sulfur is having electron configuration of 286. Will gain 2 electrons to get charge of 2-, and the electron configuration of this will have 288. Likewise, group 7 non-metals gain 1 electron to form ions with charge -1. Fluorine electron configuration is 27. will gain 1 electron to get the noble gas configuration, will get -1 charge now, and electron configuration will be 2,8. Chlorine, original electron configuration is 287, will gain 1 electron to get the noble gas configuration. Electron configuration will be 288, but will have -1 charge now. Bromine, electron configuration is 2, 8, 18, and 7, will gain 1 electron to get noble gas configuration. Now the electron configuration will be 2, 8, 18, and 8. But because of gaining 1 electron, will get charge -1. Here is an example. Complete the following table. So some particles are there and some things are missing, and we are going to complete the table. So in particle W, nucleon number 19 is given, proton number is missing, number of protons are missing, and up to so on. So number of electrons are given, that is 10, because this is electrically neutral atom. So number of the proton will be same, so 10 will be placed here, and proton number definitely will be 10 then, so 10 will be placed here. And now the number of the neutrons are missing, and because the number of the neutrons can be found by the formula of the nucleon number minus proton number, so 19 minus 10 will be equal to 9. That is the number of the neutrons. And electron configuration will be, because 10 electrons are there, so 2, 8 will be the electron configuration. Particle X is having 2 minus charge, and from this we can see X particle has gained 2 electrons. So proton number is 8, so it means there will be 8 protons, so 8 will be placed here. Because it has gained 2 electrons, so 8 plus 2, 10 electrons will be there, so 10 will be placed here. Neutrons are also already given, that is 10. So protons plus neutrons, here are neutrons 10 and protons 8. So 8 plus 10 will be equal to nucleon number, that is 18. And electrons are actually 10 now. So electron configuration will be 2, 8. Y particle is having charge +1. This shows that it has lose 1 electron. 39 nucleon number is already given, and electron configuration 2, 8, 8 is given. And from electron configuration 2, 8, 8 shows 2 plus 8, 10, 10 plus 8, 18. But it has lose 1 electron, so actually 2 plus 8 plus 8, 18 electrons will be there. And protons will be 19, because 1 electron has been lost, but number of protons will be same, that is 19. So that's why 19 will be the neutron number, that 19 will be the proton number as well. Now nucleon number minus proton number, 39 minus 19 will be equal to 20. This is number of neutrons that will be placed here. Now the last particle, that is Z3 plus. 3 plus shows it has lose 3 electrons. 13 is the number of the protons. So 13 will be proton there, because it has lose 3 electrons. So 10 electrons will be there. Okay. Electron configuration is, because number of electrons are 10, so 2, 8 will be the electron configuration. Number of neutrons are also already given, that is 14. Now the number of the protons plus neutrons is equal to nuclear number that will be placed here. This is very important question. This type of the question frequently come in the paper. So do it very carefully. Next topic is ionic bonding. Ionic bonds are formed between metal atoms and non-metal atoms. A transfer of the electrons from a metal atom to a non-metal atom enables both to achieve a stable noble gas configuration. The resulting oppositely charged ions then attract each other via strong electrostatic forces of the attraction. Here is an example: formation of the sodium chloride. Sodium chloride is formed when a sodium atom combines with a chlorine atom. That is, Na solid form, chlorine gaseous form forms NaCl, that is solid form. Each sodium atom loses one electron to form a positively charged ion Na+, so as to achieve a noble gas configuration. This electron is transferred to the chlorine atom, and here is the process of the sodium. Electron configuration is 281. It will lose the last valence electron to achieve the noble gas configuration, that is 28, and this valence electron is loose, so is having +1 charge. This electron will be given to chlorine atom. Each chlorine atom gains one electron to form a negatively charged ion, that is Cl1-, so as to achieve a noble gas configuration. Original electron configuration is 287, and it is gaining one electron to achieve the noble gas configuration, that is 288, and will get -1 charge. This is a diagram representation. Sodium is throwing its valence electrons to chlorine, and chlorine is catching by saying thanks, and both will achieve the noble gas configuration. The oppositely charged ions Na+ and Cl- are then held together by strong electrostatic attractions to form an ionic bond, and they are combined now. Figure below shows the formation of an ionic bond between sodium and chlorine. This last valence electron is throwing towards the chlorine. So this last electron will come into the outermost shell of the chlorine. Both are achieving the noble gas configuration. Outermost shells are complete now. This is gaining -1 charge, this is gaining +1 charge. Sodium ions electron configuration now will be 28, and chlorine atom ions electron configuration now will be 288. In a crystal of the sodium chloride, the ions are arranged in a regular lattice structure with each Na+ ion surrounded by 6 Cl- ions and each chloride ion surrounded by 6 sodium ions. Figure shows the structure of the sodium chloride, and here is the structure of the sodium chloride. Another example is here: formation of the calcium chloride. Calcium chloride is formed when calcium atom combines with two chlorine atoms. Here is the equation: Ca plus 2Cl forms CaCl2. Each calcium atom loses 2 electrons to form positively charged ion, that is Ca2+, so as to achieve a noble gas configuration. Here is Ca2882 will lose the last 2 valence electrons to get the noble gas configuration, that is 288, and these 2 last valence electrons will be loose. The 2 electrons are transferred to 2 chlorine atoms. Each chlorine atom gains 1 electron to form a negatively charged ion, that is Cl-, so as to achieve a noble gas configuration. Original electron configuration is 287 of chlorine. Now we'll gain 1 electron to gain the noble gas configuration, electron 288. The oppositely charged ions Ca2+ and Cl- are then held together by strong electrostatic attraction to form an ionic bond. Figure shows the formation of the ionic bond between 1 calcium atom and 2 chlorine atoms. And here is the diagram. These 2 valence electrons will be loose by the calcium atom to gain electron configuration, to gain noble gas configuration, that is 288. 1 electron will be gained by each of the chlorine atoms to gain electron configuration, noble gas configuration. So here is calcium ion, here is chloride ion, here is chloride ion. Now both atoms has gained the noble gas configuration. The opposite charge will held together by the strong electrostatic forces. Next are the properties of the ionic compounds. The first property is ionic compounds have high melting and boiling points. And the explanation for this point is the oppositely charged ions are held together by very strong electrostatic forces of the attraction, which requires a lot of the energy to overcome. Therefore, ionic compounds are difficult to melt. The ability to withstand high temperatures makes ionic compounds suitable for use as lining in the furnaces. This is the use of the ionic compounds. The second property is ionic compounds do not conduct electricity in the solid state. Ionic compounds conduct electricity when molten or dissolved in water. Explanation of this property is in the solid state, the ions are bonded together by strong electrostatic forces of the attraction and can only vibrate about a fixed position. The ions cannot move freely to conduct electricity. In the molten or aqueous state, the ions are free to move and carry an electric current. The third property of the ionic compounds are ionic compounds readily dissolve in water but do not dissolve in organic solvents. Ions are readily hydrated by water but not by organic solvents. This is the explanation of this point. Ionic compounds are made of the crystals which can be split along certain angles. This is the next property. Why do you think that ionic compounds have high melting point? The explanation is given above, which we have read Just remember that opposite charges attract, forming strong ions bonds. Imagine trying to separate all the ions in the giant structure of an ionic compound. It takes a lot of the energy to overcome all that electrostatic attraction. So this is the reason ionic compounds have high melting point. Many ionic compounds dissolve in water. To explain this, we need to look at the water molecule in more detail. The electrons in H2O are not evenly spread. One end of the molecule is slightly negative compared to the other end. Look at the diagram. The O side is negatively charged and H side is positively charged. The oxygen end of the water molecule is slightly negative compared to the hydrogen end. The water molecules are attracted to the ions and pull them from the giant structure. The compound dissolves. Its ions are then free to move around. Here is the diagram representation. Next topic in the lecture is working out formula. Look at the ions which make up each compound. Sodium chloride formula is NaCl. Ions present are 1 Na and 1 Cl ions. Magnesium chloride MgCl2. Ions present are 1 Mg ion and 2 chloride ion. Sodium oxide formula is Na2O. From here we can see 2 sodium ions and 1 oxygen ion is present. Now add up the charges on the ions in each compound. Do they balance? We can see from here plus minus will cancel out. 2 plus 2 minus will cancel out. 2 plus 2 minus will balance each other. The charge on their ions cancel each other out. Knowing this and the charge on the ions, we can work out the formula of any ionic compound. For example, here is a question. Magnesium oxide. Magnesium ions have a 2 plus charge, that is Mg2 plus. Oxide ion have a 2 minus charge, that is O2 minus. From here we can see these 2 plus and 2 minus will cancel out each other. So the charge of one magnesium ion balance out the charge of one oxide ion. This is the mathematical representation. Therefore, the bond 1 magnesium with 1 oxide ion, the formula will be MgO. And other question is here, aluminium oxide is a little more difficult. Aluminium ions have 3 plus charge, that is Al3 plus. Oxide ions have 2 minus charge, that is O2 minus. So how many aluminium ions and oxide ions combine to balance each other out? The simple way I'm telling you people is multiply this number with the other ion and multiply this number with the other ion. So it means 2 into 3 plus is equal to 6 plus and 3 into 2 minus is equal to 6 minus. So these two will be cancelled out. So from here we can see 2 aluminium and 3 oxygen ions are required. So Al2O3 will be the formula. Notice that the metal always comes in front of the non-metals in the formula. Very important point. Always metal comes in front of the non-metals. Here is another question. Element P is from group 2 of the periodic table. Element Q is from group 7 of the periodic table. What is the formula of the compound formed between P and Q? So solution is P is the metal with 2 valence electrons. P loses 2 electrons and forms a positive ion P2+ to achieve noble gas configuration. Q is from group 7, so Q is non-metal with 7 valence electrons. Gain 1 electron and form a negatively charged ion, that is Q- to achieve a noble gas configuration. So it means we require 2 Q ions and 1 P ion. So formula will be PQ2. And other question is here, which substance in the table is an ionic compound? So D, that is solid at room temperature. Electrical conductivity at room temperature is poor. Electrical conductivity of the aqueous solution is good. That's why this is ionic compound. Ionic compounds are solid at room temperature and only conduct electricity when molten or in aqueous state. Exam tip is, ionic compounds are solid at room temperature as they have very high melting and boiling points due to strong electrostatic forces of the attraction between ions of the opposite charges. In solid state, the ionic crystal lattice is intact with no mobile ions. However, in the aqueous or molten state, the oppositely charged ions are released and mobile with the ability to conduct electricity. So this was the topic. Read it again very carefully because this is very important topic and make your notes. Thank you so much.